Hello guys, good morning to one and all. In this video, we are going to see about the shortlist problem in the lead code. Okay, first reading the problem. Given the head of a linked list, return the list after sorting it in ascending order. What does this mean? Here we have a linked list as head. For example, a equal to 1, 2, 3. We say about the things like here we have head, like head in the linked list 4, 2, 1, 3. Here we need to sort it in a ascending order. What is the ascending order? From the lowest to the highest. 1, 2, 3, 4. It's the ascending order. Okay. For here they give an example 4, 2, 1, 3. We don't actually the important task here is can you sort the linked list in O of n login time and then O of 1 memory constant space. What does this mean? This means that we don't need to create any other memories to store the new array. Okay, we actually sort it in a same array. Okay, we can have two pointers, something about that, but we have O of n log n. We have as the time complexity. For this one we need to choose the sorting method. For example, if we choose the selection sort and then some other sorting methods other than merge sort, we can have the time complexity as O of n square. But we have a O of n log n means we need to choose the merge sort. Okay, first we need to learn about the merge sort. What is merge sort? Merge sort is nothing but it's a policy called divide and conquer, divide and rule policy. Okay, first we need to divide a given array into two parts and then conquer it with the consisting parts. Okay, for example, here we have the red arrows. Here these red arrows are called as divide policy. Okay, first we need to divide the arrays into two. uh, First we need to, sorry, here is the linked list. Oh, sorry, first we need to divide the linked list as two parts. Okay, first 38, 27, 43 and 3. Here we have 3 and then here we have only 3 parts and here we have 4 parts. What is the problem here? Because it's an odd array. Okay, we have to divide one part as 4 and another part as 3. That's why this happening here. Always remember that in the method we need to give the first array as one more space in the sequence of odd linked list. For even we have uh, we say that 10, we neglect the 10, and then we have the 82, 38 to until the 82 we have 3 plus 3 6. Okay, this is the even sequence. Okay, we can easily divide the 38 27 43 and then 3 9 to 3 9 82 as two different parts. Here we have the 7 sequence, so that's why we first have four numbers in the first linked list and then three numbers in the second linked list. For example, we can talk about it as array. Okay, then we need to divide it until it gets one single number in the array. First 38 27 and then 43 3, and then we have completely finished the divide policy, and then we need to rule conquer means nothing but comparing the 38, comparing the first number with the second number. 38 27, which one is small? 27. Okay, and then we are put the 27 in the first and then 38 in the second. Same as that we perform the task in the all the other arrays, and then after we conquer one by one, 27 38 3 43 9 82 10, and then here we have 3. First this it compares with the 3 and 43, and then 3 is the smallest one, 3, and then we need to compare it other numbers. 27 is the smallest one, and then we compare 38 with 3, 38 with 43. 38 is the smallest one and then 43 is the smallest one. Same as like that. Same here we need to perform the same task. After that we have the sorted list. Okay, this is the simple definition of merge sort. Now we're gonna solve the problem here. Here we have 4 2 1 3 as the problem set. First we need to create an exception. Like what? For example, if we have head as an empty linked list, for example head equals, for example, this one or this one or 1, sorry, 1. If we have head equal to 1, there is no need to sort other things because we have only one. For example, if we have only empty linked list, we don't need to sort any things in the upcoming sessions. Okay, for that we need to create an exception, like if not head. Not head means there is nothing in the head. If not head or not head dot next. This is the thing in the linked list. Head dot next means, for example, if I have 1 in the array, this 2 is the head dot next, but we have only 1 in the array, so we don't need to do some sorting things here because that's only one number available in it. So if I have head as empty list or head dot next is empty, so we simply return the head. Okay, this is the first row. This is the first exception, and then we need to choose a pointer here. For example, we need to separate the first part and then the second part. Okay, for the first part, first we have two things like slow and then fast. The slow is given as 8 and the fast is given at 8 dot next. Okay, here what we are doing, first slow and then fast. Slow means head is the original linked list, head dot next fast, and head original linked list means head is the number 4, uh, number present in the 0th position, and then head dot next is the number present in the first position. Here slow equals 4 and then head dot fast equals 2. We need to create an while loop here. For n log n, first we need to simply written as n log n means n into n log n equals, sorry, log n simply called as less than n. This is the simple manner for log n because log n is always less than the n number. Okay, for this one we need to first perform a task with a word array. We take slow and then fast, sorry, actually we are looping in the fast and then fast dot next. Why this means we are running the loop while fast and fast dot next, because fast while the fast have value and then fast dot next has a value, we are running through the loop, and then if we have then slow equals fast dot next. When we have fast and fast dot next value, we are gonna put the slow value as slow dot next. Why this means because we take the slow as first value 4 and then slow dot next means we are gonna take the slow dot next to the next value 2, and then we put the fast value as fast dot next, because we need to put the fast value as already we have take the fast dot next as value. We need to move fast value further ahead. Okay, after this one, when the loop ends, we need to choose the median, because here we have the median as 2. Median value equals slow dot next, and then slow dot next equals none. Here we are going to separate the first array and then the second array. After this one, we need to choose different two arrays, left and then the right. As we seen above, we need to sort this left and then the First, we here I'm telling that when we have slow and fast median and this median value and then the head value, we need to sort it out. For example, here from this point to this point, this is the median value. Here 3 is the median value. This is the head, okay, uh, head value, and then this is the median value. Here we are breaking this point and then make 982, 82, 10 as a secondary. We need to sort this again out. For that, we need to use the recursive method. Self dot. Here we have the method called as sort list of head, and then self dot sort list of mid. We need to sorting the head, because here we have the head and the median recursively. After this, we simply return mm, left and then the right. Yes. Okay, here we need to create another function called merge. Here we do the last part as merge part. As far as we seen about that, we seen about the divide policy. Here we have the divide policy. Sorry, this all the codes means divide policy, and then we need to conquer the remaining arrays. Okay, for the conquering, we simply take a dummy variable. Merge. Simply have list one and then the list two. First, we need to create a dummy list node of 0. Here, tail custom. As long as the L1 and L2 available here, we need to merge the things L1 and L2. First, if L1 dot value less than L2 dot value, as long as this condition passed, we need to add tail dot next equal to L1 value, and then L1 we need to move the L1 value to the next thing. Tail dot next equal to L1, and then we need to move the L1 to the next step, next one. Okay, else tail dot next equal to 2. We need to move the L2 to the next node. L2 dot next tail dot next equals okay. If for example, we have we are comparing, we are comparing this one and with this one. For example, if I take L1 as 4 values and L2 as 3 values, we the while loop is the while loop will end after L1 or L2 if any one of them is completely sorted. For example, if 3, 27 and 38 will sorting with 9, 10 and then 82, but 43 is not sorted. Then for this one we need to exclude a separate condition called tail dot next equal L1 or L2. If any one of them have any nodes, that simply added to the next element. Lastly, we need to return the dummy dot next. Okay, let's copy and then reload it. Sorry guys, sorry. Now we run it. Hmm, is the problem here? Okay, self-taught match. What is the problem? Match. Three Kibana. Okay, here we need to call the self because we are actually calling the function. Mm, okay, this is the problem, guys. Whenever I need to here, if I call this function here means we don't need to give the self one, but actually I am doing it here. Okay, after this we need to call this one. For that I need to use the self method. Okay, this is the time. Okay guys, this is all that means. Here we have analyze complexity, we have n log n. Okay, I have already finished the talk, but this gives the O of n log n as the time complexity and O of 1 as the space complexity. Okay guys, thank you. We will meet with another problem.